Hello, in this video, I will explain to you on how to solve this problem using Kirchhoff laws and showing the details, find the currents. Okay, now let's use the Kirchhoff law here. Let's use this point here because we know that this is I3 goes into here and I1 goes out from here, right? So we can use the Kirchhoff current law, Kirchhoff current law at point A. So the Kirchhoff current law said that the sum of the current that goes in will equal to the sum of the current that goes out. And here to the point A here, the only current that goes into point A is I3. So I will have I3. And then all the other currents, I1 and I2, are going out from point A. So I will have this will equal to I1 plus I2. And I think nothing that we can do with KCL from here. We need to do another rule, which is the Kirchhoff loop rule, or the Kirchhoff current, the Kirchhoff voltage law, or KVL. Okay, now let's do the Kirchhoff voltage law. And it said that the sum of the voltage in a loop will equal to 0. But before that, I think we need to draw the circuits here in more detailed labeling. So here I will have I3 in this branch, which is also the current that passed through this 1 ohm resistor here. So I will have I3 here. And then this is I1, which is the current that passed through this 2 ohm resistor because they are in series, right? And also the battery and also this 2 ohm resistor. So let's label this I1, and also let's label this also I1 because they are in series. And here I will have I2 here, and this current here is also I2. And that is also the current that passed through that 4 ohm resistor. So I have this as I2. Good. And aside from labeling the currents, we need to also label the polarity of the component. For the battery, the long one here is the positive terminal, and the short one is the negative terminal. Remember, the long one is positive, the short one is negative. Good. Now for the resistor, where the current came from is the positive terminal, and where the current goes to is negative terminal. Where the current comes from is positive, and where the current goes to is negative. Okay, do that for all the resistors. So where the current comes from is positive, and where it goes to is negative. Here I will have also like that. So this one will be plus, and this one will be minus. Good. Now let's just draw the loop. Okay, maybe let's use another color here. So for this loop, this is going up, going to the left, going down, and going to the right. So I think I will have to use counterclockwise loop here in the top loop. So let's name this as loop 1. Okay, but for loop 2 here, it goes up, goes to the right, and goes to the left. So I will have this one here as loop 2. I will go clockwise. So I have loop number 2. Okay, now let's start doing analysis in loop 1. So let's do it on loop 1 first. So we will have add loop 1. Okay, let's start from this battery here. Okay, the loop is entering from the negative terminal. So I will have minus sign. And remember, this is voltage. So I will have 16 volts. So I will have minus 16. And then we will have this one here entering to the positive terminal of this 2 ohm resistor. So I will have plus 2. And yeah, the sign is positive because it is plus, right? And because this is 2 ohm resistor, we need to multiply it by current to get voltage. Remember the Ohm's law. So I will have 2 multiplied by I1. Good. Now let's move on to this I3 here. And here the loop entering from the positive terminal. So I will have positive sign here. And we will have 1 ohm multiplied by I3 to get the voltage. So I have I3 here. Good. And I will have one more resistor here, which is this 2 ohm resistor. And the loop entering from the positive terminal. So we will have plus sign again. So I have plus, and we will have 2 I1 again. So I have 2 I1, and all of that will equal to 0. Good. Now 2 plus 2 is 4. So I will have 4 I1 plus I3. That will equal to 16. But I3 here is I1 plus I2. So I will have 4 I1 plus I2. Plus I1 plus I2. And that will equal to 16. Or we can have 5 I1 plus I2. That will equal to 16. Okay. Let's have this as equation number 1 because nothing that we can do from here. Good. Now, let's do another KVL, but this time at loop number 2. KVL at loop 2. Okay, KVL said that the sum of the voltage in a loop will equal to 0. Good. Now, let's start from this 32-volt battery. Okay, and the loop entering from the negative terminal, so we will have negative sign. And here the voltage is 32. So I have 32. And then we will have here, we will have positive sign here. So we'll have plus. And we will have 4 multiplied by I2. 4 is the resistance, I2 is the current. Multiplying them will get the voltage. Good. Now for the last component, we have this 1 ohm resistor here, also in loop 2. And the loop entering from the positive terminal here. So I will have plus sign. And then we will have 1 multiplied by I3, that is I3. Okay, and all of that will equal to 0. Good. Now we can just plug this in. So I have 4I2 plus I3 is I1 plus I2, right? So I'll have I1 plus I2. And that will equal to 32. And so we will have I1 plus 5I2. That will equal to 32. Good. And now let's save this as equation number 2. Okay, and we have turned a circuit problem into linear algebra problem. So we need to solve this equation number 1 and number 2. Okay, let's do exactly that. Okay, now we need to do is to solve 1 and 2. Okay, I think we need to write it in the matrix form, in the echelon form. So I will have 5, and then 1, and then 1, and also 5. And this one will be 16 and 32. Good. I think the first step that I need to do is to multiply the second row by 5. So I will have 5 multiplied by R2, right? So we will have 5 here. And then we will have 1. And this one will be 16. And then we will have 5. And then we will have 25. And then 32 multiplied by 5 is 120. Right? Okay, good. And what can we do next? I think we can subtract R2 into R1 and also put it into the second row, right? So we will have it like this. So I think we can use R2 minus R1, and then I will put it into R2, right? So Okay, let's just copy the row number 1. So I have 5, 1, and 16. But for the second row here, I will have 5 minus 5, that will be 0. And 25 minus 1, that will be 24. And then 120 minus 16. Wait, I think there is something wrong here. 32 times 5 is 160, not 20, right? Okay, so we will have 160 minus 16, that will be 144. And I think the second row is done here because we can solve it for I2, right? So we will have 24 of I2 is equal to 144. 24 of I2 is equal to 144. We can just divide both sides by 24, so we will have I2 is equal to 6 ampere. Okay, let's put this into a box because this is one of the answer that is looked for from the problem. Okay, and then for I1, what is I1? We can just plug I2 here into one of the equation, right? So I will have, for equation number 1 here, so we will have 5I1 plus 6 is equal to 16. And so we'll have 5I1 is equal to 10. And so I1 is equal to 2 ampere. And that is I1 here. And then for I3, what is I3? I3 is I1 plus I2. So we will have I3 is equal to 2 plus 6. And so we will have I3 is equal to 8 ampere. Okay, and I think we got all the answer, right? I1, I2, and I3. Maybe let's highlight that. So the final answer is I1 is 2 ampere, I2 is 6 ampere, and then I3 is 8 ampere. Okay, and I think we have done this problem successfully if we did not make any mistakes during my calculation. Thank you for watching and see you in the next video. Bye bye.